the y-intercept, which is what you need to graph. So we're not just picking like -2, -1, 0, 1, 2, plugging them in and making a t-chart. We're trying to graph using the axis of symmetry, the vertex, and the y-intercept. What form is the first one in? Melina? Yeah, this is standard form. When it's in standard form, Melina, what do the numbers represent? Right, the A, B, and C. So standard form is ax squared plus bx plus c. When you have something in standard form, what do you find first? What part of this parabola do you find first?
Well, you know the y-intercept's negative.
Right, so without doing any work, you can get the y-intercept because it's just c. So it's -1. This is the only form where you don't have to do work for the y-intercept. All the others you have to do work for. So it's just the c value, because if we put a 0 in for the x's, they cancel out, they go away. What else can we find? Mitchell?
The AOS.
Yeah, axis of symmetry. You need that in order to get the vertex, so that's why you have to find that before you find the vertex. Mitchell, what is that formula?
-b over 2a.
So when we take b, it's currently 4, so now it's a -4. A is 2, so Mitchell, -4 divided by 4 is?
-1.
-1. So the last thing we need is the vertex. How do we get the vertex? Sarah? Yeah, so this is the x of the vertex. It's also the x of the axis of symmetry. So you're plugging in the -1 into the equation. So the equation has a 2, x is now -1, and then a 4 with a -1, and then -1 up by itself. So when you square a negative number, every time you square a negative number, it's always positive. So that's now 2 times 1, -4, -1. Sarah, do you know what the y value of the vertex is? Yeah. So the vertex happens at -1, -3. So we found the axis of symmetry, we found the vertex, we did calculate those two. The y-intercept is just given in the problem and it's in standard form. So if we go to graph this, graphing the axis of symmetry at -1, the y-intercept is on the axis of symmetry, but it's down at -3. Or the vertex is on the axis of symmetry, but it's down to -3. And then the y-intercept is at 0, -1. So using the mirror image part, because of the axis of symmetry, I can also get a point on the other side of the axis of symmetry at -2, -1. So those 3 points are fairly close together. To get a parabola that's a little more detailed, I can pick 2 other x points. How do you choose those 2 other x's, Sarah?
Well, you just like pick the next point. So
Yes.
it would be 1
So 1,
and -3.
perfect. And she said it like you just choose the next point that's on your graph. So my 2 values that I have for the y-intercept and its mirror, you just go 2 beyond, like just go beyond those points. So it's just 1 on either side is how you would find them, the next values that you would want to use for your x. So you could pick a 1, you could pick a -3. Plug in either one of those, but it's going to give you the same y value because they're the same distance from the line of symmetry. So if we use the 1, plugging it into the problem, we would have 2 times 1 squared plus 4 times 1, and then -1. So this is 2 times 1 plus 4 minus 1 gives us a value of 5. So again, whatever x you pick, look at your graph and just go 1 beyond with the points that are currently on your graph. So use the graph to help with those points that you're choosing. So the last 2 points, we have a 1, 5. And then -3, 5, and they should be symmetrical. So both those points should be 2 away from the axis of symmetry. So when you connect those points, this is a narrow parabola. So it's a little longer than normal. It's facing up because there was a positive 2 in front. It gets more narrow because that 2 is bigger than 1. Anytime the A is bigger than 1, the graph should get narrow. Any questions with the standard form? So if you look at B, the one in the middle, this form has one set of parentheses and it's square. The number outside, what's the negative 3 do to the graph? Mitchell?
It makes it narrower and
Right, so it's going to make it narrower and it flips it down instead of going up like the last one we just had. That's the only part that really affects. The other numbers, the 1 and the 2, what do they find in your graph? Alina? Yeah, the other numbers find the vertex. This is called vertex form because the vertex is in the equation for you. So the numbers in parentheses and outside that are being added out the back, that gets you your vertex. So the vertex is at 1, 2. Remember your vertex is your H and K. That's what those numbers represent. It's the opposite of the number inside the parentheses. That minus is not attached to the 1. The 1 is totally separate because this graph really moves to the right, which is why that vertex is a positive 1. So if you know the vertex is 1, 2, you also know the axis of symmetry because the axis of symmetry has the same x as the vertex. So in vertex form, without doing any work, you know the vertex and the axis of symmetry because they're in the problem. They're even 2. The other part that we need to calculate is the y-intercept. So Alice, when you find a y-intercept, what do you have to do to find a y-intercept? Yeah, and what do you plug in for x when every time you find a y-intercept? So if we're on the x-axis, or the y-axis, what's the x value on the y-axis?
Oh, 0.
0, yeah. So to get the y-intercept, it's 0 comma something. In the first form, it's 0c, but there's not a c in this problem. And the plus 2 is part of the vertex, because it tells us our vertex moves up. So we have to actually find the y-intercept by plugging a 0 into the problem. So 0 minus 1 is negative 1, but negative 1 squared becomes positive 1. So Ben, our y-intercept is? Negative 1. So we have the axis of symmetry, we've got the vertex, we have our y-intercept. Every y-intercept can be found by plugging a 0 in for x.
I was just wondering why it was a 0. Is it just because that's how it is?
Well, if you're on the y-axis, you're not moving anywhere left or right on x. So it's always 0 because it's not shifting left and right. Other questions? So when we go to graph this, we have an axis of symmetry at positive 1 on the x-axis. The vertex is 1, 2, so my vertex needs to go up 2 on the axis of symmetry. And then the y-intercept is 0, negative 1. So I have 3 points plotted again, because I'm using that y-intercept to give me a mirror point on the other side of the axis of symmetry. So we still need 2 more points. We've got this curve part here, but let's see if we can get 2 other points to kind of see how steep the graph will be. So again, when you're looking at those 2 final points, go 1 beyond the points that you already have. Noelle? Yeah, so negative 1 and 3. So if I'm just going 1 beyond the points that you currently have, you're at negative 1 and positive 3. And again, you can plug either one of those in. So if you'd rather plug in the positive 3, because you're going to get a positive number, doesn't matter. So Noelle, we have negative 3 times 2 squared plus 2.
2 squares. 4 times negative 3 is negative 12. And negative 12 plus 2 is
the 3 points are already graphed. We've got 2 more. At -1, we're down to 10. And at +3, we're down to 10 as well. So this graph is even more narrow than the previous graph. The distance between those points vertically, they're spreading out more, and that's because there's a 3 there and not a 2. So everything's being tripled instead of being doubled. Questions? Lexi?
So we need more than like negative. Or like saying it's zero.
The negative just says it goes up or down. So it's not that it's more negative, it's just that the 3 is bigger than the 2. That's why it's more narrow. So if there was a 4 or 5 there, it just continued to get skinnier and skinnier. But the negative just, the only thing that does is puts it upside down. Other questions? So then the last form that we talked about on Thursday was there are 2 sets of parentheses. So there's a negative in front. Brady, what's the negative in front of the parentheses due to the problem? Right, so it inverts it, it flips it, it reflects it. Does this one get wide or narrow, Brady? No, because there's just a 1 there. So this is just a standard parabola. The parabola just goes down because really the one number in front of the parentheses is just a 1. Does anybody know what the numbers inside the parentheses represent? Emma?
The x.
Yeah, so the numbers inside are the x-intercepts. So this is intercept form because without doing work, you can pull the x-intercepts out of the problem. So Emma, what are your x-intercepts?
1, 7.
Yeah, so 1, 0, 7, 0. Emma, how do those x-intercepts help you find other parts of the graph?
Can you plug one of the x's in?
We have to use them somehow. Emily, you want to help her out?
To find the axis of symmetry, we do e plus q over 2.
So the axis of symmetry is in the middle of the x-intercepts, no matter what. Everything needs to be symmetrical with the parabola. So if you have these 2 points on the x-axis, the axis of symmetry is going to cut those 2 points in half. So if we add them together and divide them by 2, Emily, you get x equals 4. So x-intercepts you get from the problem, the axis of symmetry would be in the middle of those x-intercepts. And then to find the vertex has an x value of 4. Take that, plug it back in to get the y. So we have 4 minus 1, 4 minus 7. So Shaylin, -3 times -3 is?
Or
9. Questions? So we can find one final piece here. We could get a y-intercept. Or you could get 2 other points. But if you find a y-intercept, it actually ends up getting you 2 other points. And again, any y-intercept has an x value of 0. Because you're not moving left or right, you're just moving up or down on the y-axis. So if you plug a 0 in for x, we would have 0 minus 1 and 0 minus 7. What's the y-intercept value? Jalen? Yeah. Because this makes a -1, that makes a -7, so you get 0 and -7. Any questions? So graphing this time we have 2 points on the x-axis, because that's what we found from the given equation. 1, 0, and the other one is 7, 0. And then in between is my line of symmetry. So if you draw this and your line of symmetry doesn't split the parabola or those 2 points in half, then you calculated the line of symmetry wrong, because when you draw it, it should be directly between those two x-intercepts. The vertex is up at 9. And now I've got this u part of the parabola, and then the y-intercept is down at 7. And you don't have to find another pair of points, because if you use the mirror image or the reflection, if I count over 4 to get to the y or the line of symmetry, I go 4 more to get to the other point to mirror the y-intercept. So this graph is a little larger than the others because there wasn't a number in front. So that's why the graph is going to be wider. It's going to look like a bigger graph if the number in front is a 1. It's not shrinking it at all. Any questions on the 3 forms? Does that clarify some things? So I'd like you to take out the word problem part of your homework. So the first problem that you were asked to complete was 55. The setup was already done for you for 55. So the model is already given. The price, if I'm finding revenue, I have to take how much something is, we're charging for something, the cost of something, minus or times the sales that we have. So anytime you have revenue, it's always what is the cost times how many are you selling. So we're going to try and set up a similar function for number 56. So my equation should look very similar into the way 56 or 55 was set up. So an electronic store sells 70 new cameras per month. About. The price of the camera is $320. For each $20 decrease in price, they're anticipating that they could sell 5 more cameras every month. So the first part says write a function that models the situation, and then we want to decide how the store can maximize the monthly revenue. Meaning, how many times should I reduce the cost so that I can sell the most number of cameras, but also benefit from the largest profit or the largest revenue? So if we have revenue, we're going to set up the problem pretty much the same way as the one above. So we need to think about the cost or the price per camera. And you're going to multiply that by the number that are sold. So that's how I would set up a revenue equation. But we need to take into account that we're going to reduce the price in hopes to sell more. So if we start off with the cost, how much does a camera cost us? Emma? $320. And what is our goal? What are we doing with the $320, Emma?
Like, you want the next?
Yeah.
Oh, okay. We're trying to decrease it by 20 something.
By 20 something. The reason you put an X there is because the X represents the number of times you're actually taking the price reduction. So the 20 is reducing it 1 time, but what happens if I want to reduce it 2 times or 3 times or 4 times so that I can sell more cameras and therefore get a larger profit? So that's why the X is in the problem. The X represents that cost reduction that you're applying to the problem or applying to your cost. How about the number of sold? Emma, what do you have for that one?
70.
So we sold 70 cameras, but if we reduce our price, what are we hoping to do?
Add 5 per month?
Yeah, add 5 per month. So we're going to put a 5x there. Again, that x means every time that I reduce the cost, I should sell another 5 cameras. So if I reduce the cost twice, I've reduced it $40, but if I'm reducing it twice, I should then sell another 10 cameras instead of 5. So the x represents the number of times that you should reduce your cost. Questions with that? So here would be my function. So that function represents the revenue that I would have based off of my cost reduction. The question then continues for us to find the maximum monthly revenue. So if you're trying to find a maximum of a quadratic function, where does the maximum occur? Emily? At the vertex. So anytime it says find the maximum of a parabola is always at the vertex of the parabola. Emily, how do you find the vertex? Right, you need to first find the axis of symmetry. The axis of symmetry gets you the x value. The maximum is actually the y. So in this case, Emily, do you have this foiled out? Perfect, thank you. So that would be the 2 parentheses foiled. When you FOIL them, you get a negative 100x squared plus 200x plus 22,400. So if I'm finding the max, we have to first find the axis of symmetry, which would be negative 200 divided by 2 times negative 100. That gets you a value of 1. What does that 1 mean? Elena?
You should decrease the price like $3.
Right, so that 1 just means you're reducing the cost just one time. And that price is just by $20. So if this was a 2, then it would say I should reduce my cost twice or by $40. But that 1 represents the number of times you're reducing the cost. So we're just reducing that cost once by $20. So my price reduction should be $20. To get the y, there are 2 things that you could do. Question, Megan.
In the equation, shouldn't the x be 3,000x? That's what I got.
The x should be what?
3,000.
This here?
Yeah.
Um,
Can we maybe foil?
no, I'm pretty sure it's right. Because you have 320 times 5, so that's 1,600. These guys here is 1,600, and then you're subtracting 1,400, the minus sign, because it's a decrease instead of an increase. So make sure you have a minus sign. If you have a plus sign there, then you would get the 3,000.
It's just weird. Because like the x is usually
If you want, you can rewrite them. Just make sure you keep the minus sign in the problem. So when you plug in the 1, you could plug in the 1 into the FOILed problem. Or you could plug in the 1 into the x's right here. Because it's already in multiplied form, and just by plugging a 1 in, you have 320 minus 20, so that's 300. 70 times 5, or 70 plus 5 is 75. You're multiplying then 300 by 75. Either way, you should get a revenue of $22,500. So that would be the max revenue for 1 month that we would earn just from selling the cameras by putting them on sale for $20. Questions? Emma.
Okay, so I know how you get to the step where you have like the equation and you're finding the answer, but why do you, like, to answer the question, how are you able to figure out like, how to answer the question?
Based off the fact that it says maximum, the only place a maximum occurs is the vertex of a parabola. And the only way you can find a vertex of a parabola is by using negative b divided by 2a. So like the maximum doesn't occur anywhere else on the graph of a parabola. Just like the minimum doesn't occur anywhere else. So a maximum or a minimum only happen at the vertex. So if you need to find the vertex, the way we can find it is by using negative b divided by 2a. Nowhere else in the graph will give you a maximum value. Other questions? So the other problem that I wanted to go over was the Golden Gate Bridge problem. Anybody travel over the Golden Gate Bridge in San Francisco? So huge bridge. And this is just a little snapshot of what the bridge looks like. But every so many feet there are these pillars or towers. And the towers have a cable that connect one to the next. And it's just repeated. So it's a repeated group of parabolas throughout the whole bridge. And the cables support your bridge so that it doesn't cave and kind of collapse in. So the equation that's up here, we will learn how to calculate this equation. We'll start doing some of the calculations at the end of the chapter. Next year in Trig and Pre-Calc, you'll really dive into how to get those equations in physics. So right now, the equation that models this parabola in the Golden Gate Bridge from one tower to the next is 1 over 9,000 x squared minus 7 over 15x plus 500. So that equation represents this arch. That arch is a parabola. So the arch from one point to the next forms a parabola. The x represents the horizontal distance that you would travel across the bridge. The y is the vertical height from the base of the bridge to wherever the cable is landing. And our goal is to figure out the height of the cable at its lowest point. So essentially, what's the distance from the lowest point of the cable to the base of the bridge? If you're finding the lowest point, what do you need to do to find the lowest point? The minimum value. So if we're finding the lowest point of the cable, the lowest point is the same thing as finding the minimum value, n, which Noel is the same thing as finding the vertex. And again, the only way to find the vertex when it's in standard form is to use negative b over 2a. So you kind of have to relate that lowest point means minimum value, which means I need to calculate the vertex in order to solve the problem. So for all of those problems on there, no matter what problem you were looking at, whether you're getting a max or a min, you need to find the vertex, which you have to start out with x equals negative b divided by 2a. You need to take this answer, which for this one it ends up being 2,100 feet. But you have to take that answer and plug it back into the equation to get the y, because the y is the minimum or the maximum part. So it's a two-step problem. Like you get x, but you have to use x to find the minimum or the maximum. Questions?
Can you just go through the problem for me? Like, for all the different steps.
Well, what would you do to find the x value? Because whether it's a word problem or a graphing problem, like it's the same thing. So how would you find the vertex?
Would it be 7/15?
So 7/15 divided by
1 4,500.
So yes. So 1 over 9,000, or you said 1 over 4,500. So then you're taking 7/15 and you're multiplying that by 4,500 over 1. And that makes the 2,100.
And then what do you do for the
So you need to take that, just like if this is your vertex, this is my x value. How do you find y?
So you just enter
You just plug it into the problem. So just because it's a word problem, it doesn't change the way you're solving things. Like, yeah, there's words to it, but the equation is still an equation. And once you find x, that's your x value that you need to plug in to get the corresponding y. That part doesn't change. So the method is the same, we're just not graphing it. You're just looking to find the vertex in a different way without focusing on the graph. Instead, you're just using the process. Other questions? So when you came in, you picked up a review worksheet which has probably 25 graphs on it. There's 12 in the front, 15, 7 graphs. The ones that I'd like you to practice for tomorrow's quiz are on the board on the left side over here. So the first page is 13, 15, 13, 14, and 15. So those like 3 second row problems. Check this scale. Your graph should fit on the graph that's given, so you don't need any other kind of graph paper. But they have it scaled by 2 so that it fits on the graph. And then on the back of that page, 7, 8, 12, 13. And then on the last page, 16, 18, 20. Those are at the bottom of the last page. Those are the 3 problems to multiply FOIL to get it into standard form.
You only have to do those ones.
Only those. If you'd like to do the others, feel free. There is a word problem tomorrow. There are not any word problems on the review worksheet. But you can go in your book, you can look at the other word problems for sections 4.1 and 4.2, and they pretty much ask you to do the same thing. So I did not have time to come around and check your homework. I'd like you to just pass it forward. Try and like just fold the top. If it's not stapled, just like fold the page over so they stay like flipped together.
Does this one?
So I want the word problems and the worksheet along with the graph. So you should have 3 things that you're passing forward. So the graph paper, the worksheet, the word problems. Again, just fold it over, like the corner, just fold it over so they stay together. Question? The equation? Yeah. Make sure you put your name on that. 5 of you didn't have names on the worksheet the homework that I just passed back. The solutions to the review should have been sent to your Remind app, and they're also on the Google Classroom. It's to all of the review, so if you want to do other problems, feel free to.
You should not roast me. This is hilarious.
Seems like a big number, but
You thought the same.